Back. We're going to be looking at how a cloud forms today. And a cloud is essentially water that is in the air. And under certain circumstances, the water is a gas. And other circumstances, water is liquid. And if you have liquid hanging out in the air, it usually rains. So often you're going to see that precipitation comes from clouds. Now, all clouds don't have enough water to make it rain, but we'll talk about that in another lesson. So first of all, I want you to set your mind up for this. If you were to take a big block of ice and put it in the water and pull it down below the water and release it, it would pop up. Or if you would take a beach ball and put it under the water, it would pop right back up. The reason it would pop up is because liquid water is denser than the air, even including the weight of the ball. If you put the beach ball plus the air, all of that together is going to be less dense than the water is. So the more dense liquid water will always sink, and the less dense beach ball will float. Same thing with the ice. Ice, even though you would think of it, I'd hate to get hit with it, but ice is less dense per volume than the water. So it will float on the water. Whatever is less dense floats. It works exactly the same in any fluid. So liquid is a fluid, but so is air. So if you have something less dense, it will float up. So a helium balloon will float up. If you release it, it'll go up into the sky. If you were to have a balloon full of carbon dioxide, which is a denser gas than regular air, it would fall to the floor. Okay, so you blow into a balloon. Most of the air you've got in your lungs is carbon dioxide that's coming out. And so when you tie that knot, it doesn't just hang out in the air, because you'd think that it should just sit in the air. But the balloon has a little bit of weight, plus the carbon dioxide is more dense, and it sinks. So if you were to heat air, some of the things that's going to happen in air is that it's becoming less dense. The reason it's less dense is because you give those molecules more energy and they spread apart. They're getting hyper, they're moving around, and they're spreading away from each other. And as that spreads away, you're going to have the same amount of stuff, the same molecules, in a bigger space. So if you put the same molecules in a bigger box, they're not as crowded as they were. The smaller the box, the denser and the more crowded they are. The bigger the box, the less dense that they are. So if you heat air, it becomes less dense and it starts to rise. And as long as you've got air that's less dense than the air above it, it continues to rise. So warm air will continue to rise until the density of that air is exactly the same as the density of the air that it stops in. Once it's exactly the same, it just stops. It doesn't continue to go higher. So what's happening is that let's say you have air above a campfire or air above a hot asphalt road in the summertime, that heated air is going to expand and rise. And then as it does, it rises and displaces the air that's there. The colder air sinks and the warmer air rises, just like a lava lamp. That's how a lava lamp works. And as it rises in the air, it's going to continue to rise and cool off because it's farther away from the fire, farther away from the road. And when it cools off, eventually it's going to stop. Now, if you were to have dry air, completely dry air, it will be about 5.5 degrees Fahrenheit for every 1,000 feet that it goes up in the air. So it just keeps climbing 1,000 feet. It's 5.5, less, and then less, and then less. So it's going to drop off in temperature. If you were to have water in that air, something weird happens. That water can hold a lot of heat. It takes a long time for water to boil on the stove because it can hold heat. So that water in the air can hold heat. So if you have wet or moist air that is warm and it starts rising, it will cool off about 3 degrees for every 1,000 feet. Okay? Now, what will happen eventually is it's going to get cooler and cooler and cooler, and the water is going to saturate the air more. All right, so let's go back to another idea. If you were to have air, let's say you have a big container of air, warm air can hold a lot of moisture, lots of heat, a lot of moisture, a lot of water. Cold air doesn't hold as much. Okay, so that's why there's dew on your bicycle and on the grass when you wake up in the summer, because it's cooler in the nighttime. That air doesn't hold on to as much water, and so the water dumps off onto the grass and onto your bicycle, and that's why it's wet. About 10 o'clock, 11 o'clock, the sun is up, and that water off the grass dries up into the air. So the air is holding it. Warm air holds more than cold air. So let's imagine you have a big sponge, huge sponge, and it's got a cup of water in it. That sponge could hold more than a cup. So it's not completely full, it's not saturated, right? So what if you had a smaller sponge and you still had a cup of water in it? Well, a smaller sponge could possibly hold a cup, but it would be more full than the other one. Let's say it would be 70% full. Well, what if you had even smaller sponge? A cup of water might completely fill it, and it would be 100% full. Anything less, and the air can't hold that anymore, and it starts falling out as rain. And that's where rain comes from, and snow, sleet. We'll talk about that later, right? So the heated air rises up, it expands, it cools off, and it starts condensing. The liquid, the gaseous water vapor starts coming out as water. And that water, if you were taking a shower and you've got a steamy room that touches the bathroom mirror, all of that hot, moist air touches the bathroom mirror, it's going to instantly dump its heat and cool off and turn from gas water into liquid water. And that's why you've got your mirror is fogged up. Essentially, that's what's happening in the sky. You've got little dust particles called condensation nuclei. See it over there. Condensation nuclei are little dust particles that attract the water, it pulls out of the gas phase into the liquid phase and becomes gaseous water. Once you've got water, liquid water in the air, you can't see it anymore. It becomes white. It's no longer transparent. You can't see through it. It becomes translucent. You can see light through it, but you can't see through it. So that's where the cloud comes from. That cloud is where you've got liquid water vapor hanging out in the air. And then whenever it gets to 100% saturation, when the sponge drops so much, it will start precipitating. Okay? So atmospheric lifting is when you have hot ground or a hot campfire and that air rises, and if it has moisture in it, it eventually can create a cloud above something. You can have clouds above a river real easy, or a lake. Above a lake, that's where clouds can think. You're going to have hot water from the lake on the surface that will then go up into the air full of water, and you can end up with a cloud. So you can have clouds over the Great Lakes. You can have clouds even over the oceans. That's where hurricanes come from. Those are all clouds full of moist, heat, energy air. Okay. The last thing here is orthographic lifting. So ortho meaning rock. So you're going to have essentially mountains that get in the way of a cloud. So if you've got a cloud that's got moisture in it, and the wind is blowing that cloud and it hits into a mountain, well, it could drive that cloud up the mountain because it doesn't have anywhere to go. The wind is blowing it into the hill, and it rises up the hill. Well, the higher it gets, the colder it gets. The colder in the atmosphere you get, up to a level, is going to get colder and colder. Well, the colder it gets, the sponge shrinks. The more the cloud can't hold water, because the colder the air, the less water it holds. Eventually, you're going to get 100% saturation. That's called the dew point. And when it reaches the dew point, you're going to have precipitation. So a lot of times on a mountain, the cloud will hit the mountain and then dump on one side. It'll rain on the other side. Then the cloud goes over the mountain and there's nothing on the other side. You're going to see that in the Sierra Nevadas. California is going to have lots of rain on one side. Then on the other side, it's a desert because there isn't any more water there. All right. I hope that was interesting to you. I got some of it, and see you in class.